So in this experiment, we're going to study friction. So let's say I have an object. I'll just use this box of weights as my object. It's sitting on a flat surface, right, horizontal surface. And let's assume that I exert a force in this direction. So I'm pulling on the object in this direction, but it's not moving, okay? So if I pull, let's say, 2 newtons in this direction, it's not moving. Therefore, there must be a force that's resisting the motion so that the net force is 0 because it's not moving, it's not accelerating. So if I pull with 2 newtons, there must be a force in the opposite direction parallel to the ramp, also of 2 newtons. And in this case, that force is called a static frictional force. Static meaning it's not moving, okay? If I pull harder, let's say I pull now with 3 newtons and it's still not moving, then that static frictional force is going to increase. It's now going to become 3 newtons. So again, when you sum the two, you get 0, right? 3 newtons in this direction, 3 newtons in that direction. That's going to sum to 0. You can keep doing that until the object is on the verge of motion. So now if I pull even harder, let's say I'm pulling with 5 newtons and it's just ready to start moving, well, since it's still not officially moving, it's still a static frictional force, but since that's the largest that static frictional force can be, we call that Fs max, the maximal static frictional force. So if I pull with 5 newtons, it's on the verge of motion, then the force that's resisting the motion is going to be a maximal static frictional force, Fs max, and its magnitude would be, in that case, 5 newtons. So that's static friction, okay? And I'll do another video explaining some of the theory more carefully. The other type of friction is kinetic friction, and that is when the object is moving. It could be accelerating, it could be moving at a constant velocity, but if it's moving, the frictional force that's resisting the motion is what we call a kinetic frictional force. So what we're going to do in this lab is we're going to pull the cart. In this case, our object is going to be the cart with the weights on the cart here. We're going to pull that cart at a constant velocity so that there's no acceleration. Remember, constant velocity means 0 acceleration. So that means the net force should be 0. So the force that I'm pulling with, and we can measure that force, is going to be equal to the kinetic frictional force, the force that's resisting the motion. Right? So let's say I pull with 4 newtons, then I know, and I'm pulling at a constant velocity, then I know that the kinetic frictional force in the opposite direction is going to be 4 newtons. All right? So we're going to do that, but we're going to do that with the cart here. Now if you look at the cart, there are these 2 leather pads on the bottom of the cart. So really we're looking at the friction between those 2 surfaces, the leather pads and then the wooden ramp here, between those 2 surfaces. Okay? So in terms of the data collection, what we want to get is we want to measure Fs max and then Fk, so the maximal static frictional force and the kinetic frictional force. So the way that we're going to do that is we're going to set up the cart. Actually, you're going to have 4 conditions. You're going to have the wooden cart with 2 square weights, and then with 3 weights, 4 weights, 5 weights. Okay, I'll just show you for one of these conditions, and I'll collect the data, and I'll give you a table with all the data in it. Right? But let me walk you through how we actually collect the data. So let's say I have the condition with 3 weights. So I'm going to start this at some location. I have the force sensor connected to the string here, right? So this is going to measure the force in newtons. I'm going to 0 it, so when there's no tension in the string, I'll 0 the sensor, make sure it's actually recording 0. Then I actually have a graph display, and I'll show you this more carefully later on the document camera. I'm going to press play. I'm going to slowly pull this, and I'll pull the string horizontally until the cart starts moving. So it's going to resist motion, it'll give a little bit, and then I'll keep pulling it at a constant velocity. So it kind of gives, and now I'm going to pull it at a constant velocity. Actually, that's good. I'll stop, and then I'll stop the recording. I'll stop play. So from that graph, we want to calculate the maximal static frictional force and the kinetic frictional force. So let me show you how how to do that next.